Welcome back to the shop, guys. Well, all I can say is I had a spare motor kicking around and a bunch of extra plastic. So I tried an experiment inspired by Stefan Gosswinter, and I hope I'm pronouncing his name right. So I'll put a link in the description to the motor. If you guys want to try it, I'm thrilled to death with this thing. Okay, next project. I think it's time to make one of those lapping machines like Stefan Gosswinter made. And he did his, I think what he was using was a windshield wiper motor. This is the power feed off the lathe right now. I can always order another one, but I figured let me just use that for now. It's 260 RPM, something like that. Worm gear, whatever. So my thoughts were, this will be the base because it's nice and small. It'll easily hold that and put that on center, right? Yeah, I can go back. And the wheel would be like ooh, that's pretty close to the front. I may have to make a deeper base. I don't know. But I was thinking, plastic, fine. Just use this as the base, and I was going to just cut all the sides here and just completely silicone it. That way it's sealed. If I wanted to put oil or water or something in there for the wheel to spin in, I can do it. I'll have one piece of plastic in the center, which will be the mount for the motor. Not sure where we're going to put the power switch yet, probably on the corner. Can use any transformer. 12 volts is what that guy is. So the height isn't much. It's almost like I'm just ripping this in half. I'm going to send everything through the table saw, all the same height. And then for the angle, I can just angle a side piece here, cut it at an angle, and then do something for the tilt. I could even put a piece of plastic here with a pin in it to tilt. I don't know about the tilt yet or the switch, but that's the thought so far. And I've got, is this deeper? No, it's a fraction deeper. No, not as wide, and I've got holes because I was using this for something else and screwed up on it. But I've got other pieces. So it's just a matter of probably cut all the sides first and then think, oh yeah, this is going to be thinner. So I don't have to worry about that. I'm going to have to cut this off somehow. I've got some 4-inch discs on order, eBay, a diamond one. But I've got this, I think it's like a sandpaper or something on order. So, because mainly I'm going to be probably messing around with high-speed steel rather than carbide. But since it was like $6, $7 for a diamond wheel, why not? Put magnets in it like Stefan did, so everything attaches. So it's just a matter of thinking about it off camera. Pretty good so far, I think. I don't know. So, moved it. I made a new bottom, so I've got a lot of room in the back. It's kind of a kick because the wall goes here. That's a sealed area. So I can put a transformer in there or whatever to run the motor. Plenty of clearance for the motor. And I was thinking about making a flange thing, where it comes out, goes over, and it's a bigger piece with 4 holes, and screw it to the back. So that keeps it nice and straight. I can control that. This will go on the bandsaw. I'll use some V-blocks to cut it off, and it easily fits in the 4-jaw to clean up the face. So I'm now super parallel, perfect flange to the motor, everything's straight. What else was I thinking? And then I still have the front compartment. Like I said, if I wanted to put some oil in there or something. But now I'm trying to figure out what to do with the angle. And it was kind of a kick because everything's 7 degrees. Cut this at 7 degrees, put a piece on top because this is 7 degrees. 7 degrees. The front is 7 degrees. 7 degrees. Oop. So I can always put, stand them all up, I can always put a piece on the inside, a rod underneath it, and the rod goes through the sides, have a shoulder to it, and then turn it down and put wing nuts on it so I can loosen them, angle it more, tighten them up. The only problem is if I'm 7 degrees and I want to go 10, I'm going to hit the front. So I don't want to take the front down even more, but I could barely have anything for a front. You can take it way down and just the sides at 7. I don't even need, well yeah, I do need a front if I want to put fluid in there. So now I got to pick up some silicone and just start putting this part at least together. And I'll probably, no, I can't put it together yet because I got to make my final decision here on the angle. I can't leave it as is because again, if I put a piece here and angle it, I'll hit the front. So I can't do that piece. I have a feeling I'm just going to do 7 degrees. And that's it. Silicone, I can easily tear it apart if I need to really, you know, over time find out I need something different. I don't know what that angle is. I should put the precision protractor that I got from Banggood on this thing and see what the angles are. But even if this is more of an angle, I can still just 7 degrees and hit the tip. That's all I care about, is getting a razor sharp edge and a nice round to it. So I think I'm just going to go for 7 degrees. Move the camera in a little closer so you can see this. Decided on 7 degrees, so it's angled, precision. Wanted the angle to start at the face, but I overcut it. So now the angle starts at the wall, which is fine. I'm above center. How much? Yeah, quite a bit. Oh yeah, like a 1/2 inch. So I could run the bottom, cut the bottom all through the table saw and lower the whole thing down. I'll have to think about that. But I was thinking, you know, everything's supposed to be 7 degrees. Start making the tools right for 7. Because something I put on here and I said, no, that's not right, but it'll work perfect for all the D-bit stuff beautifully. And I'm sure a lot of other stuff too. Oh yeah, I still have this guy out. Oh yeah, it should do this just fine, huh? If I can set it on there carefully. Eyeball it. Oh yeah, sweet. Aye, there's the light. Yeah, so this is going to be good. Just start making the tools correct rather than making this wrong to deal with wrong tools. So, beautiful. All right. So I'm going to quit for now. That way I can think about it. Maybe something else pops in mind. Also, the cool thought is I can, since there's a wall here, make a piece of plastic that fits just down in there and then glue it to this. That way I can have a lid for the whole thing, and you just take it off and put the switch on it with kind of a long wire or something. I was thinking about putting a transformer, full weight bridge cap in there, be done with it. I don't have to have an external transformer or anything. Just have a power cord coming out and plug it in. Beautiful. And then I always could still make something where I can change the angles, but so it's pretty cool so far, I think. Just some comments on this. This is definitely something you do not want to do by hand. And you can see I have a V-block in there. I've seen a lot of people just clamp something round in a vise without a V-block. You wind up with simply a 2-point mount, and it's going to move. Especially if you're trying to mill something off, you have to have at least a 3-point mount to keep it from tilting, pivoting, or moving. Also on this big a job, you know, this long a cut, usually this is when the belt or the saw blade, whatever you call it, breaks at the weld where it's put together. But this time I've got the belt tighter than usual, so I have and it's lasting a lot longer doing even small jobs. So I have a feeling the tighter it is, the less flexing happens at the weld. So I don't know, but I'll see. It's not even at, it's close to halfway. It's been running for about 15 minutes, my guess. I could slow it down more, and I see the same amount of chips coming out, so it would be traveling less distance at a slower speed, cutting the same amount of material. But for this guy, I'm running it on what is it, like 2? I don't know what feet per minute that is. I used to have it written down, but I lost the piece of paper. So let's see if it hangs on. Sorry about the lighting. I think I've shown this trick before. This is, yeah, I think this is the, it's 3-inch vise. Where's my brush here? It's pretty dirty. All right, get some junk out of it. But yeah, I had made these things. I still have to clean these holes out. They're full of garbage, so can't get it all the way down. But basically put this back here, because there's no way I can hold this to do the machining, or this guy, because I need to put the 4 holes in it for the flange thing that I'm going to make. So this comes out. This comes out. It takes forever to try to get the other one out. Alright, come on. There. How did I put that in there? Oh, it was just nicely put. Okay. That's pretty nice. So these come out and then they switch around. So I'll bring you back when I've got that done. Instantly a huge vise, and it holds it solid too. So the only thing is, I don't think the edge finder can find the edges, so I've already made a little mark where I have to start what I would call the 0 datum point. Then use the touch DRO to move to make the 4 holes to mount the motor. So let me, yeah, I guess I'll use, where is it, this guy, because it'll just give me the point, so I'll be close enough. This isn't that critical. So camera on this side, it just might be better lighting. So yeah, DRO, everything, a lot of math to figure out where to put these holes. Looks correct. And this is why I like the rack extension, because there's no way I could get the height before to do this. I want to take it all the way out to this diameter so I can grab the full shaft with my little fitting or whatever to the wheel. And it does have a bearing in it. There's no play in it, which is nice. So it's a matter of just boring the heck out of it here. Just trying to hold the camera over the magnifying glass, and I think that's in focus, I hope. What happens if I do it without, huh? Yeah. So last video I was talking about your tool, your insert being exactly on rotational center, how the chip's going to roll off of it. This is a 7/1000th cut, and you'll see the chip rolling off of it. It just rolls right off the top. Unfortunately, this creates a major long piece of swarf, but I gotta pay attention because I don't want to run into this thing. But if you're not on rotational center, then you're not gonna get that. Alright, whoop, wrong knob. Trying to finish this off. There, back it out. So if you're above rotational center, you're not going to get a finish like that, and if you're below, you're going to be more or less scraping stuff. Kind of hard to set the camera up for this, but I think it was the last video I mentioned about being absolutely on rotational center, and this is going to be an example of it. Aluminum. This is just my generic that I use for everything, steel or whatever, and I'm getting a pretty good finish with it. But this is on rotational center, and you'll see the chips are just curling right off the top of this thing. Yeah, I guess I can do it without oil, but oops, I forgot to go in. These are 7/1000 cuts, so that's 7 right there. Dare not push it any further here because I'm poking way out. See, the chips just curl right off the top. Unfortunately, it gives you very long, yeah, it's going all the way around the lathe on the floor. There, it finally broke, though. But you can see the finish is pretty darn good, especially if we're going in this direction, which I say doesn't give me a great finish. Almost got to manually stop it here for the last fraction, just bring it in. But yeah, chips just curl right off. Now, if that were below or above rotational center, finish would be completely different, and you wouldn't see the chips curling off of it like that. Somewhat of an update so far. Had to take that out. I got all the holes in it, bored, everything. So it's re-silicon, that's just drying, setting up here, curing. Got the part done here for the motor. A real nice tight fit on it. Still need to finish this side. And was thinking just 3 holes here, using the touch DRO to the plate. So the idea is that goes on there like that. And if there's any wobble outside or anything like that, I can resurface that through this. So should be working out pretty good. I got the transformer, the aluminum oxide discs. I was thinking about just gluing, I think it's just paper I'm getting, lapping paper, gluing it on there. Then I've also got a diamond coming, which should be on a steel plate. So I'll put magnets in here, then put the paper on it. Then if I need to use the diamond, I'll just stick it on top of the paper. But let's see how it goes. It's 4 micron aluminum oxide lapping paper, it says. So, and I got a pretty good fit. It rocks. I mean, I know I'm right on it, but so drill this out too for the set screw. Probably dead center. Yeah, I'm just worried about anything wobbling or run out or something like that. I should be able to deal with it though. That'll look pretty good. So far, so good, huh? Alright, so kind of that's it put together here. Just kind of checking it in the lathe. And I do have quite a bit of that number. So I got to oversize these holes so I can get rid of that. Otherwise I can turn it, but I just wanted you guys to see this one. Considering how many surfaces. Oh, back it up. Is it in focus? There you go. Oh, slow it down. Slow it way down. So what have I got there? What is that? There's a half. So it's 1.5 thou, I think. So not too bad. I guess you can probably see this bobbing up and down if I go a little faster. I should redo it just to see. Oh, that's quite a bit. I can see it moving. You guys probably can too. So, don't know where I want to go from here. I do have the set screw down in there for the motor. Probably let me just put it on the motor, see what it does. Well, I consider this a success. Holy cow. Yeah, to get this guy, all the air out of it, I put a gauge pin in it, stuck it back in the lathe, redid this so there's no more wobble this way, and then redid the face. I did get today, look at these things. These are crazy, man. 25 pack Unilap. What is it? 2 micron PSA film, lapping film. Lucked out, it is self-adhesive. Pulled the back off, stuck it on there. I don't have any magnets, so I couldn't do that first. And then stick it on there, because I did get the diamond one. I forgot what this was. 800 grit right here, 4-inch. So I have diamond if I want to do carbide, and I've got that, and I did test it. I put some rubber feet on it so it doesn't move, but you can see, I think in the camera, let me take a look. Yeah, you can see there is no wobble anywhere, and I did it to this guy, and it's now a ridiculously sharp edge. Holy cow. Both edges on it. I just held it like that, and then like that, and you can tell if you're at the right angle because you can get the black buildup here. You can start seeing, okay, yeah, now I'm getting a whole face. So this is going to be a blast. I got to try this out in the lathe because this is going to be insanely sharp now. Wow. So kind of looks ugly with all of this silicon in here. Terrible, and it makes a funky noise. I don't know what happened here. Oh, alligator fell off. I'll be just using the transformer. So there is some final stuff to finish up here, but I don't know where this clunking sound's coming from. So yeah, I did turn it down, so now it's smaller than 4 inches. I don't know how to trim that off, but it sticks on there pretty good, huh? Yeah, so this will be a blast. Small enough that I can just stick it up in a corner so it's not in the way. Cool. So if you guys want to try something like this, the plastic I had kicking around, you can make it out of, be nice if I could make this out of plate aluminum or something. So I may come back and rebuild this thing some other way, but for now I have something I can actually use.